How can you identify rational versus irrational numbers in algebra? Imagine you're trying to figure out if a number can be written as a simple fraction or if it just keeps going forever without repeating. That's the key to understanding rational and irrational numbers. In algebra, knowing the difference helps you solve problems more easily. Rational numbers are numbers that you can write as a fraction with two whole numbers. For example, 5 can be written as 5/1, and 3/4 is already a fraction. Decimals like 0.666 repeating or 0.75 are rational because they either end or repeat a pattern. If a decimal stops after a few digits or repeats a set of digits over and over, it's a rational number. On the other hand, irrational numbers are a bit trickier. They cannot be written as a simple fraction. Their decimal forms go on forever without repeating. Think of the square root of 2, which is approximately 1.414235. You can't write it as a fraction, and the digits never settle into a pattern. Numbers like pi, which is about 3.14159, are also irrational because their decimals never end or repeat. To tell if a number is rational or irrational, start by asking if you can write it as a fraction of two whole numbers. If yes, it's rational. If not, it's probably irrational. Next, look at the decimal form. If it stops or repeats, it's rational. If it keeps going without repeating, it's irrational. For example, the square root of 9 is 3 because 9 is a perfect square, so its square root is a rational number. But the square root of 7 stays as it is because 7 isn't a perfect square, making it irrational. Remember, some special numbers are always irrational, like pi and Euler's number, which is approximately 2.71828. Recognizing these helps when solving algebraic equations or simplifying expressions. For instance, if you see the square root of 25, you know it's 5, a rational number. But if you see the square root of 30, it stays as it is because it's irrational. Understanding whether a number is rational or irrational helps you decide how to work with it. If it's rational, you can convert decimals to fractions easily. If it's irrational, you'll know the decimal will go on forever without repeating. This knowledge makes solving algebra problems smoother and helps you see the true nature of the numbers you're working with.